when I find the area of this, of one petal, I know that either the way that I have it looking or the way the calculator looks, it may not look like that the area is the same. But no matter which petal you choose, all the areas will always be the same, and it will always be that way even if there's 3 or 4 or 10 petals. Okay? So if I just find the area of any one of them, then it's going to work. Now, the calculator tells me that if I start here, that angle's 0, and if I go to here, that angle was 30, right? Yeah. Okay, so if I want to find the area here, if I find the area from 0 to 30, that's not going to give me a full petal. It's only actually going to give me the area of one petal. I mean, half of a petal. Does that make sense? Because it's only from 0 to 30, just that top part of it. Okay? Now, on your calculator, if you keep moving from 30, keep pressing trace. If you go from 30 until it gets back to 0, 0, which is at 90, that trace is a full petal. So if I do this right here from 30 and then back to 90, that would trace a full petal. Do you see that? So when I'm doing this, one way I could do it is I could find the area from 0 to 30 and then multiply it by 2. Since from 0 to 30 is only that little top part, if I multiply by 2, that would give me the bottom part too. Or I could do the integral from 30 to 90, because that traces that whole petal there in the third quadrant, which would be the whole thing. Does that make sense so far? All right. There's a formula for polar curves to find the area. It has to do with arc length and sectors and things like that. I'm just going to show you the formula at this point, just another one you need to memorize. But if you want to find the area of certain things in polar form, it's 1/2 times r squared. And it's d theta, meaning that theta will be in the problem. The good thing about area on these, you know, with y's and x's, sometimes we had to do top and bottom and left and right and all of that. It's always just one way. It's always just dealing with like where the angle starts and where the angle ends and trying to deal with the angles. Okay? So it's not x's and y's like that. So as far as the formula, it's really easy. If you can figure out how to set it up, the formula is not bad. All right? So it's either one of those ways, and then it's 1/2 times the r squared. You can put the 1/2 on the outside if you want, but it's not squared. So that's what it looks like, I think, when I graph it. When you have like sine of 2 theta and cosine of 2 theta, usually that like tells you something about how many petals there are. If it's an odd number, I think that's how many petals there are. If it's an even number, it's like twice the number of petals or something like that. And if it's sine, this happens, and cosine, and it does different things. But anyway, I know that I want to do the area of one of them, but I don't really know where the 0, 0 starts, so that's the reason that it's important to graph it, see where it starts, and try to use those angles to make one complete petal. So it looks like if I start at 0 and then go to 90, that makes one complete petal. So it should be 0 to pi over 2, 1/2 times r squared. It says interior of that. Basically, it just means inside of it. On some of the work you're going to have, it says like interior of the convex limacon or interior of the cardioid. It doesn't matter what the words say. They're just telling you the name of the figure that they're drawing, and they just mean inside of it. So don't make that confusing. If you graph it, this one is a cardioid, I think. Looks kind of like that, which sort of like a heart. And what they said in the instructions was to find the area of the inner loop. So it's asking you the area of only that part right inside of there. Okay? So you're going to have to play with it a little bit to think about what angles that would help that to make that work. So it looks like 120 would start it here. And then it goes like on the bottom and then up until you get to, is it 240? Now remember that if you're trying to change that back to radians, think about 120 as being something times 60. So it's 2 times 60. 60 is pi over 3. So it's 2 pi over 3. And then 240, well, that's 4 times 60. So that would be 4 pi over 3. And then what do y'all get for the final answer? 7 is the same picture, but it says between the loops. So what do you think that is asking there? It's asking about this outside part right here. So just think about it a second, like without thinking about the angles in the graph or whatever. Just logically, what do you think that you could do to find the area that it's asking for? So find the whole thing and then subtract the little thing that we just found. Now, the hard part when we do the whole thing is that if you start at 0, 0 starts here, right? And it'll make the whole top part when I get to here is the 120, right? Well, then it takes a break and does a little loop, and then it does the bottom part. You can't just go 0 to 2 pi because that would make the whole thing. You have to think about not the little loop, okay? So what you're going to have to do when you do it is like do from 0 to 120 and multiply it by 2 and then subtract the little loop. Because since the loop's part of the angle that you have to make to get to 2 pi, you can't go from 0 to 2 pi. So I do 2 times the area from 0 to 120 to find the top and the bottom, all of the top and the bottom, without the inner loop, and then I subtract off the inner loop.
I didn't do that either. I did that.
So let's say that r equals 2 is one of the things, and r equals 4 cosine of the angle, and it wants you to find the area to the right of the picture. And I don't have a good way to describe that, but we will graph it and look at it. They call it bounded by that, where both of those are a bound of the picture. So first thing you want to do is graph it. So graph it, and then we'll talk about how we go about doing this. I hope that you know what r equals 2 looks like without having to do anything. The blue one is the r equals 2, and then the purple one is the r equals 4 cosine theta. So when they say bounded by, that means that they're trying to find something where both of those are a part of the figure that is shaded. So it's asking for this area over here. Now, before we think about angles and everything, just kind of talk me through it a minute. Like, what sounds like something that you could do to find that area? So the area of the one on the right and the area of the one on the left and subtract them. Okay.
Area of the small, like you find your, could you do it? Yeah, find the.
Okay, so it seems like we're going to have to do something with the degree from here to here. Do you agree? Okay, so start there and start figuring out what those degrees are.
60.
So 0 is where it starts, right? As far as the degrees. And then if you trace it up there on the top, that's pi over 3 or 60. Do you agree? Okay, so let's just focus on that part of it, because if I could find that whole top part right there, what could I do to the answer? Multiply by 2. And that's what I usually do, is if I can get one part of it, I usually try to multiply it, just because it makes it easier to not have to think about all the angles. So if I started, which one do you think would come first? The 4 cosine theta or the 2? The 4 cosine theta, because it's farther away from the axis, right? So if I'm trying to find the area, it seems like if I could find like maybe all of that, because when you're doing your angles are coming from 0, 0, okay? So it's like you're starting at 0, 0 and going out to it and then going up. So it's finding that whole purple part, really, is what it's doing, until it gets up there. I guess I should probably do this a little bit better. It's finding it until I get to right there. So that little part is kind of cut off, okay? But then I need to subtract off something, and what am I going to subtract off? The circle part of it, which would be this part right here. And since that circle was the inside part, I'm just going to subtract it off. Okay? Try to set it up and see if you can get it. Okay, so this one is r equals sine of 2 theta and r equals cosine of theta. And it is the part that is sort of intersected by these two things. And it's kind of different because the sine of 2 theta has a bunch of petals, and the cosine of theta is a circle. So I'm going to graph it first, and then we'll talk about what it wants to find. So it looks like what it wants you to find is this part right here. Do you agree? Because that would be the part that, if they're intersected, that they have in common. Now, the angles and everything's kind of weird here, so I'm not going to talk to you about it yet until you get a chance to sort of look at the angles and see how they play on each one of them, and then I'll sort of talk to you about it. So play with the angles a little bit, kind of look at it, think about the intersections, and then we'll talk about it. And okay, so the first, it starts here at 0, and it goes to here, which is 30, but which part of the picture does that actually make? Is it the top part of the petal, or the part that's intersection, or the bottom part of the petal? What is that actually making? It's actually making this part right here. Do you agree? And so what's going on is that it's making part of it. Okay? Now, if I keep going from pi over 6, that goes outside of the part that's even intersected. Do you agree? Okay, so what's next? Okay, and so where does 90 occur? Okay, so if I go from pi over 6 to 90, now if I keep on the same curve, that's this part right here, right? But if you move it to the other curve, if you move it to the cosine of theta, and you go from 30 to 90, that makes, I'm trying to change the color, that makes this part right here. Do you see what I'm saying? So from 0 to pi over 6, we would get this part, and that has to do with the sine of 2 theta, because that's the bottom part of the petal. But then if I go from pi over 6 to 90, that would get the top part of the intersection, but that is actually of the graph cosine of theta. Does that make sense? So are we going to add here, or are we going to subtract? We're going to add. So on the first one we subtracted because we found like the bigger area and we subtracted the smaller area. On this one, we're finding this little bitty area on the bottom, and then we're finding this little bitty area on the top that we're going to have to add together to get that whole intersection. But then that's not the answer. Then you have to multiply by 2. Okay, so try to set it up. Okay, let's say we have r equals 1 plus sine of theta and r equals 1. And the instructions on this one, I think they say inside this one and outside this one. So I'm going to give you a second to graph it, kind of look at the angles, and then I'll talk to you about it. It looks like the one that's sort of outside everything is the blue one, so in the calculator I'd probably play with the blue one a little bit to look for the intersections. Do you already have the intersections? What are they? Okay, and then so you could find like the whole top part of the blue, and then what would you do? And then you can subtract like the bottom to purple. Now, I will tell you on the free responses that I've been looking at, what they do for the purple is they just do the area of a circle, or half of an area of a circle, instead of using the formula. But if you would prefer to use the formula, then that's okay too. But that's what I've seen them do. So. 2.785 is what I got. Basically the blue minus the purple. Alright, we're going to do one more. Inside both might be the instructions there or the intersection of those two things. Talk about just the angles a minute. If you're looking at the purple one starts over on the right at 0. It goes to 45 where the intersection is, and then goes to 90 like at the origin. What part of that's actually important though? In the part that we're trying to find the area of, what part of the purple is important? The 45 to 90 part, right? Okay. So if you look at the blue one, it starts at 0, it goes to the intersection then up. What part of the blue one's important? Okay, so what do you think you could do here to find the area? So you could do the integral of the purple one, and what would be the angle? Pi over 4 to pi over 2. And then you could add that to the integral of the blue one from 0 to pi over 4. And you still have to multiply by half because that's the formula. Now you could, let me tell you this as well, you could do the integral of the blue one from 0 to 45 and then multiply by 2. You could also do the integral of the purple one from 45 to 90 and multiply by 2. Because when you divide that in half, they're both equal. Or you could just do the two separate integrals that we just talked about. Okay, so what I actually want you to do, we'll do more with the ones like this, the intersections tomorrow. But your homework, I have a worksheet which says quiz on it, but it's not really a quiz. It's just a worksheet that we're going to work on. It'll be due Friday. It has parametric and vectors on it. And then also on yesterday's worksheet that we were doing, on the same side as what we were doing, I want you to do, I think it's 43 through 50. Yeah. And that's that same worksheet from yesterday.